Hello everyone. I'm still doing mathematics paper 1, the May-June 2024. I'm about to do calculus. I'll start doing question 8, then I'll do question 9, which is a cubic function, and question 10. Okay, firstly, question 8. We are asked to find the derivative of f of x by using first principle. Whenever they say by using first principle, we use this formula that says limit as h approaches 0, f of x plus h minus f of x over h. They say limit as h approaches 0. For f of x plus h, we'll go to f of x, and whenever we see x, we will substitute with f of x plus h. Then we'll have 1 over x plus h minus 1 over x all over h. When they say find the derivative by using first principle, our main objective is to find the derivative and then substitute 0 whenever we see h. But in this case, we cannot do that because h is at the denominator, and if we substitute right now, we will get 0 at the denominator, and 0 at the denominator will make the entire thing to be undefined. So right now, our mission is to eliminate this guy here. So remove it, putting out the denominator. Okay. Whenever you deal with fractions, I don't like working with fractions within a fraction. So what I'll do is to multiply the top and bottom by the lowest common denominator. My lowest common denominator will be x. Let me write properly. X and x plus h. X and x plus h. So that means I'll multiply every term on the numerator with the LCD and every term on the denominator with the LCD. So as I move forward, I'll have limit as h approaches 0. If I multiply 1 over x plus h with the LCD, the x plus h will cancel because this one is at the denominator, that one is the numerator. So I'll be left with x, and that x will multiply the 1. So I'll be left with x minus, whenever I take 1 over x multiplied by the LCD, the x's will cancel. Then I'll be left with x plus h multiplied by 1, which is just x plus h. And then now I'll still have my h, x, and x plus h because they're multiplying. Then when we move forward, I'll still say limit as h approaches 0. Now I'll remove the brackets at the top. I'll have x minus x and minus h all over h, x, and x plus 1. This thing is equal to limit as h approaches 0. I'll have a negative h there at the top, h, x plus h. These two will cancel one another because everything is multiplied, and if everything is multiplied, whenever I'm dividing things that are the same, they will cancel one another. So this will go with this guy. So I'll be left with limit as h approaches 0 minus 1 over x plus h. Now I can substitute my h as 0, because whenever I do that, my denominator will not be equal to 0. So I'll just say 1 over x plus 0. Let me use a different color. X plus 0. And please note that whenever I substitute 0 as my h, I no longer write limit as h approaches 0. Are we together? So this thing will be just equal to minus 1 over x squared. So this is how you find the derivative by using first principles. The equation was f of x is equal to 1 over x. Whenever I saw h, I put x plus h, and then I substituted and did my mathematical gymnastics until I got there at the bottom. Okay, for the second part, 8.2.1, I'm told to determine this here. I have the square root of 4x to the power 6 plus the square root of 2 multiplied by x squared. Whenever I'm given an expression like this expression says derive with respect to x everything that's on the right hand side. So this thing here tells me to derive with respect to x. That means whenever I move to my brackets, I must derive everything that has x. And anything that doesn't have x is regarded as a constant, and the derivative of a constant is equal to 0. Okay. So here in this case, for me to find a derivative, first I must remove sets, brackets, and fractions. So in this case, I have sets, and I'm only to remove sets on the unknowns I'm trying to derive. If I don't have sets on the unknowns, I'll just leave it like that. So I'll have d of dx equal to this will become 2x to the power 3 plus root 2 multiplied by x squared. So now I no longer have sets. So whenever I derive, I will use this rule here. That's if f of x is equal to a x to the power n, therefore my derivative will be n multiplied by a and then n minus 1. This simply means I'll take my exponent, multiply with the coefficient of the variable I'm deriving, and then I'll subtract 1 on the exponent. So in this case, I'll have 3 multiplied by 2, which is 6x, and then 3 minus 1, I will have 2. And then on this case, I'll have 2 multiplied by root 2, which is 2 root 2, and then 2 minus 1 is just 1, so I wouldn't write a 1 here. So please note, guys, you must keep on writing d over dx, but as soon as you write your derivative, you don't have to write it again, because d over dx tells you to derive. So as soon as you are writing the answer to your derivative, you don't have to write d of dx. Okay, let's move to 8.2.2. I'm given g of x 3x to the power 4 rather, and 4x squared plus 6 all over x squared. Okay, for me to find the derivative, I must not have fractions, sets, and brackets. In this case, I do have fractions, so my first objective is to remove the fractions. So g of x, and in this case, how can I remove the fractions? X squared is dividing each and every term that is in the numerator, so I'll just do so as well. I'll say 3x to the power 4 all over x squared minus 4x squared all over x squared plus 6 all over x squared. So whenever I divide 3 to the power 4 over x squared, I'll be left with 3x squared. In this case, I'll be left with 4, and here I'll just remove this x squared from the numerator from the denominator to the numerator rather, by using the exponential rule. That says if ever I want to remove a number from denominator to the numerator, I must just change the sign of its exponent. So in this case, I'll have 6 to the power x minus 2. This thing is equal to g of x. Please note, before I'm not writing g prime of x before I write my derivative. So now I'm about to write my derivative. That's when I'll start writing g prime of x. So therefore, g prime of x will be equal to 6x. The derivative of a constant is always 0, and then in this case I'll have minus 12 like this, and then my answer is complete here. But if I want to if I want to leave my answer with positive exponents, I can do so as well by using the same rule. I can just say g prime of x is equal to 6x minus 12 all over x cubed. Right, together. And then on the last question 8.3, I'm told that the equation of a tangent to this curve at x is equal to 1 is given by that. Okay, our equation of a tangent y is equal to 9x minus 9, and this is a tangent to which curve? To f of x, which is given by 3x squared plus bx plus c. Okay, I'm told that this line 9x minus 9 is a tangent to f of x only when x is equal to 1. Only when x is equal to 1. Okay, so now I know that x is x supposed to have its corresponding y value, so that I'll have a complete point, and that point will be the point of contact of the tangent and the curve. So for me to find the corresponding y value, I can just substitute my x value on the equation of the tangent, because x lies on both the tangent and the curve. So I know that when x is 1, this thing simply means my y value is 0. So my point of contact between the tangent and the curve is 1 and 0. My point of contact between the tangent and the curve is 1 and 0. Okay. However, I also know that for my curve, this is squared, not cubed. For my curve, the derivative of my graph my gradient will be equal to 9, since 9 is the gradient of my tangent, and my gradient will be equal to 9, but my derivative will only be 9 if and only if the x value is 1. So that means for me to continue working on the derivative, I can only substitute 9 if I can only substitute x as my independent variable, or as my x value. So I now know that the value of b will be equal to 9 minus 6, which is equal to 3. Are you together? So this thing simply means that my f of x is equal to 3 x squared plus 3x plus c. For me to find the value of c, I must just substitute the point on my equation, because I know that my y value is 0, but this happens if and only if my x value is 1. Therefore, the value of c will be equal to -6. So that was question 8. Let's move to question 9. Let's move to question 9. Let's move to question 9. Okay, question 9, I'm given the equation. It's like this. Okay, I have my turning point there. The x value at my turning point is 1, and the x-intercept is 5. Y 0, x-axis. I'm told that f of x is equal to ax cubed plus bx squared plus cx minus 5. So I can conclude from this information, I can just conclude that, okay, my y-intercept will be -5, because the constant term of a cubic function will always tell me about the y-intercept. Okay, first question, I'm asked to show that a is equal to 1, b is -3, and c is -9. Okay, whenever I'm given a graph like this, the examiner is telling me what are the x-intercepts. So I'll just write my graph in this form. A is equal to x minus m and x minus n all squared. And here I'm saying all squared because when x is equal to -1, I have it's the same as me having two equal roots, because the graph turns at the x-axis. So in this case, I know that f of x will be equal to a x minus 5 and x plus 1 all squared. This thing shows that the graph turns at the x-axis, this part. So firstly I must find my value of a, right? But I can only do that if I substitute a point on the graph. I do have a point on the graph, my y-intercept. I know that y is equal to -5, but this thing only happens when x is 0, because for y-axis x is also for on the y-axis x is always 0. Are we together? So whenever I see x, I'll put 0 there. So I'll have -5 is equal to -5a. Divide both sides by -5, and then I'll have a is equal to 1. So now I know that a is 1, and they did tell me to prove that the value of a is 1. Yeah? Since I know that the value of a is 1, I can therefore say f of x is equal to x minus 5 and x plus 1 all squared. I'll just expand these brackets. X minus 5, then here I'll have x squared plus 2x plus 1, and then the other bracket will, this bracket here will multiply that bracket, ne? So I'll have x cubed plus 2x squared plus 2x minus 5x squared minus 10x minus 5. So I'll have x cubed minus 3x squared, because of a positive 2 and a negative 5 will give me a -3, né? And then why did I have okay, and then a positive x and a negative x will give me -9x, ne? I made a mistake here initially. I said x multiplied by 1 is 2x, which is a big mistake. Okay, and then a positive x minus 10x will give me -9x, and then I'll have my -5. So therefore my a is 1, b -3, c is -9. And then on the second question, I'm asked to find the x value for which f has a local minimum. Now I know that f of x is equal to x cubed minus 3x squared minus 9x minus 5. Ne? I can only get a local minimum when the derivative is 0. So I need to find my derivative first. I'll have 3x squared minus 6x minus 9. For the local minimum, my derivative needs to be 0, and then just solve x. I'll have 3x squared minus 6x minus 9 is 0. I can divide everything by 3. I'll have x squared minus 2x minus 3 is equal to 0. I can factorize this thing. I'm looking for factors of 3. That's when I subtract will give me 2. That's 3 and 1. And the bigger factor will take the sign of the middle term. So x is equal to 3, or x is -1. When I look at my graph, I have two stationary points, two turning points. Né? The other one must be a maximum, and the other one must be a minimum. The one which is above the other is the maximum, and the one which is below the other is the minimum. So I know here at my maximum I was given that x is equal to 1. So that means for my minimum, x is equal to 3 at the minimum value of f of x. And then now I'm asked to interpret the graph. Okay, but to use the graph to determine the values of x for which 9.3, for which the second derivative of x multiplied by the derivative of f is greater than 0. Okay, in this case, what you just need to do is to just try to think about this thing. What is it saying? You have your graph here. This is -1. You will have a 3 here, since you just found out now. They want us to find the values of x for which f double prime of x multiplied by f of x will be greater than 0. So in this case, I am multiplying two things and my answer is greater than 0 or positive. That thing simply means those things must have the same sign. Are we together? So they said I must use the graph. That means I must also draw the second derivative function. My first derivative function, I know it will move like this, but I'll erase it. This will be the x-intercepts. Are we together? This will be the x-intercepts, but I don't want to have a first derivative. I want to have my second derivative. It will look like this, and here my x value will be 1. Are we together? So please don't worry about this. I will upload videos later on to explain the graph interpretations. In this case, explaining the cubic function and its derivatives. Okay, so just to answer this question, I want to know, where do my graphs have the same sign? Okay. For my derivative graph, I know that my derivative graph is positive when its y is positive. So just for in simple terms, just know that your graph is always positive whenever it's above the x-axis, and your graph is negative when it's below the x-axis. Are you together? So I will just indicate those with a red ink. So when my graph is above, I know I'll have these now, and then when it's at the x-axis, it's equal to 0, and then it changes. Below the x-axis, it becomes negative. Are you together? But for my f of x as well, is the same thing. When my graph is below the x-axis, it's negative. When it's above the x-axis, it's positive. So my graph is positive from here, 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 here until infinity. But just below here, it is just negative. And here it's equal to 0. Are you together? So in this case, I want to know where is my derivative function and my f of x positive at the same time, or where are they negative at the same time? I know that when x is greater than 1, from 1 to infinity, my second derivative graph will always be positive. But for the cubic function, it starts being positive when x is equal to 5. So when x is greater than 5, both my second derivative and my f of x are both positive. So here I'll say x is greater than 5. Are you together? And then I know that when x is less than 5, my cubic function is forever positive, except when it touches the x-axis here at x is equal to 1, it becomes 0 there. Are you together? But for the second derivative, it starts being negative when x is less than 1. When x is less than 1. So I can just say here x is less than 1, but x cannot be negative 1. It cannot be negative 1 because here at negative 1, x is not negative, x is 0. Yeah, so both my cubic function and my derivative have the same sign when x is less than 1. Okay, and now they want me to know for which values of t will the graph have 2 distinct positive roots and 1 negative root. Same thing applies here. You're just interpreting rather. I have a function like this, and I'm told that another function p of x is formed by just adding t from f of x. So this thing simply means that p of x is equal to x cubed minus 3x squared minus 9x minus 5 plus t. Are you together? So for this one, it's simple. I just need to know the y values that at my turning points. I know that my y value here is 0, and when x is 3, let me just find out what is the y value when x is 3. Punching minus 3 x squared minus 9x minus 5. This is negative 32. Okay. So here I just need to show this by just drawing a vertical line. Please note, whenever I draw my vertical line here, I only have one root, which is positive. And the question said we must have 2 distinct positive roots and 1 negative root. And please note, whenever I draw my graph just below the turning point, I only get 1 root as well, which is negative. So this doesn't apply. Are you together? So this doesn't apply. But please check, whenever I draw my horizontal line rather, between the 2 stationary points, I get 3 distinct roots. But please note, whenever my horizontal line is above this y-intercept, I will have, I will have 3 distinct roots, but 2 of them will be negative and 1 will be positive, and that's not the scenario I want. I want to have two positive roots and one negative root. So here, that's the situation I want, and here that's the situation I want. So my value of C, my value of T should be just between this thing here, which is -5 and -32. Now let's move to question 10. Question 10. Question 10, we are given a figure there. Yeah. Excuse my drawing. No. This is not giving congruent triangles. Okay, in this case we are told that we have triangle MNP, and we have a shape here FG, E and H. There's a D there, and then this size is x squared, and this one as well is x squared. This one is B. The entire length is 4, and I'm also told that these two are equal. Okay. I'm supposed to show that the area of this rectangle is given by this ax 6 x squared minus 3x to the power 4. Okay. What can I deduce from the information I'm given? Okay, this one is 3 centimeters. Okay, from the information I'm given, I'm told that triangle, what did they say? Oh, they told me that NM is equal to MP, ne? So this thing simply means that triangle MNP is an isosceles triangle. If it's an isosceles triangle, it means that these angles are also equal, ne? Okay, so I can conclude that these two triangles are congruent. Why? Because in triangle MNP and triangle MDP, ne? I know that MD is a common side together, and I'm told that MN is equal to MP. This thing is given to me, and I can conclude that angle N is equal to angle P, because these are base angles of an isosceles triangle. It's true because MP is equal to MN. So therefore, triangle MNP is congruent to triangle MDP, ne? its side, and angle. So if they are congruent, I can therefore conclude that ND is equal to NP, which is 2 centimeters. This is equal to this. Does it make sense? So I know that, okay, ND wami, here I have 2 plus 2 will give me the entire length of 4. For me to find the area, I must find the length of EH. EH is simple because I know the entire length is 4, but outside I have x squared and x squared on the other side, so it's 2 of the x squared I must subtract from the 4 to get the length of EH. Are we together? And then for FE, what can I do for FE? I must use my ratios. Guys, we work here. I'm sorry that I have to write a lot of things for 4 marks, but I want you to understand everything. In triangle NFE and triangle NMD, this is NFE. I know that angle N is a common angle. Angle N is a common angle, and I'm told that this thing is a triangle, so that thing simply means that angle NEF is equal to angle NDM, because both angles are equal to 90 degrees. Are we together? And so that thing simply means angle NFE will be equal to angle NMD, angles of a triangle. So I can therefore conclude that triangle N is similar to triangle NMD. So if the two triangles are similar, that means the corresponding sides are in the same proportion. The corresponding sides are in the same proportion. When the corresponding sides are in the same proportion, it simply means that FE over MD will be equal to NE over ND. And this thing is true because triangle NFE is similar to triangle NMD. Excuse me. So FE, it's what I want. It's given as B. Let me just write B. B. MD, it's 3 units. NE is x squared. ND is 2. So I'll just say B is equal to 3x squared over 2. So now I know that, okay, whenever I find my area, therefore my area will be EH multiplied by FE. I know that EH is 4 minus 2 x squared. HE is 3 over 2 x squared. Whenever I multiply these things, I'll get 6 x squared minus 3 x to the power 4. Yeah, we worked there for 3 marks, for 4 marks. Okay, now let's move to 10.2. But calculate the maximum area. It's simple. Now I do have the formula area, x squared minus 3 x to the power 4. Maximum area, I need to find my derivative first, which is 12x minus 12x squared, x cubed rather. For maximum area, my derivative should be equal to 0. So I know that 12x minus 12x cubed must be equal to 0. So I can take out a common factor here of negative 12x. I'll be left with x squared minus 1. I have two things multiplied and the answer is 0. Is 0, or x squared minus 1 is 0. So here x is equal to 0, x squared is 1, x is plus or minus 1. All together. So for me to find the maximum area, I'll just substitute the value of x here to the power 4. Whenever I substitute positive or negative 1, I'll get the same thing because both my exponents are squared. So I'll just say 6 and I'll get 3 centimeters squared. So that will be my maximum area. Guys, I hope you understand. I know the video is long, but I believe it's worth listening to. Please subscribe to our channel and wait for more content. Bye, y'all.